Let's talk about overfitting. Before we understand rich and lasso regression, understanding overfitting is really important. Now we have our cost function j of theta naught comma theta 1 is equal to summation of 1 by 2m into summation of I is equal to 1 to m h theta of xi minus yi whole square. Right. Now let me draw the graph y-axis and x-axis we have. Now let's say that we have 2 points here in this axis and which is passing through the intercept 0. That means theta naught is equal to 0 here in this case. Now what will be our cost function for this graph? The cost function for this graph is 0 because the actual points are lying on the regression line. The main aim of this cost function is to minimize the value, right? Is to minimize the value. So here it fits the best line here. It is exactly passing through these points. So there is no difference between actual points and the regression line. Actual points and the predicted points. So here we will be having the cost function j theta naught and theta 1 will be equal to 0. But let us say that we have some points here lying before this regression line, okay, which are having far from the predicted points. Now here comes the problem. These red points are the training data and these black points are the test data. Now for training it is okay, but when we are doing the test it is having a big difference from the predicted line to the actual point, which gives a huge error. That means there will be a high variance in the test data. Now here comes the overfitting problem. Here I can write something like this. Model performs well, model performs well, model performs well with training data, with training data, but model but model fails to perform well, model fails to perform well with test data. When we are talking about the training data, we are talking about the bias. Okay, here we have low bias. Okay, when we are talking about the test data, we are talking about the variance. Here we have high variance, right? Low bias and higher bias, which will give a problem of overfitting. Similarly, we have another problem which is called as underfitting, which is called as underfitting. In underfitting, what we have is model accuracy is bad with training data. Here, model does not perform well. Here, model does not perform well with training data. Training data. That means it is having high bias. Okay, and also this model does not perform well with test data. That means it is having a high variance, high bias and high variance, right? So these are both overfitting and underfitting problem. Now let's see some three scenarios. Let us say that we have a model 1, we have a model 1 having training accuracy which is 90% and test accuracy we have 80%. Okay, and we have another model, let us say model 2, let us say model 2, we have a training accuracy with 92%. Let's say some test accuracy is having some 91%. Okay, now we have another model, let's say model 3. Here training accuracy is training accuracy is 70% and test accuracy is 65%. Now, by observing these values, what we can say here? By observing these values, we can say this is having an overfitting problem, right? This is having an overfitting problem. Means overfitting means here the training data is having low bias and high variance. And in the model 2, I wanted to discuss this later. Let's go to the model 3. In model 3, what is happening? Here we have training accuracy 70% and test accuracy is 65%. Both are not performing well here. That means it is an underfitting problem. Underfitting problem. So in underfitting, what is happening? It will have higher bias and higher variance. So these both models are not actually good. So we have another model which is called a generalized model, which is a generalized model. Here what we have is we have low bias and low variance. So this is the best model because our training accuracy is also good, our test accuracy is also good. This model is not good because of training accuracy is good but testing accuracy is not good. And this model is not good because training accuracy is bad and test accuracy is also bad. So now we have our generalized model which is having lower bias and lower variance. Now there are few things here to discuss about overfitting and underfitting. We have two regression techniques called as rich and lasso. Rich can also be called as L2 regularization and lasso can also be called as L1 regularization. So let's talk about these regression problems in our next video. Thank you for watching.